In this episode, I will describe another 10 future descendants, 5 animals, then 5 plants. We will start with Falsus gramen, the first undiscovered species in this series. Falsus branched into 3 paths, with Aquatilum luteum retro, Caledon falsus, and Ludius falsum. Aquatilum luteum retro. Aquatilum is bigger than its Falsus ancestors by a small margin. Although still having the suction cups for sticking to walls, Aquatilum is semi-aquatic, swimming in lakes and ponds but rarely venturing up or downstream due to the energetic demands and dangers. Most of the brine cells on Aquatilum are on its back to get ample sunlight while swimming. The rest are on the tips of the arms. Aquatilum reproduces differently than its Falsum ancestors. Instead of making a small salt nest on a cliffside, they simply let their eggs float on the surface of the soda away from the shore, all while the mother keeps the eggs from floating to the shallower portions. After hatching, the babies are right on top of their mother to gain their energy back, but after they leave, they're gone for good. Caledon falsus. Caledon has less limbs extruding from its main body. Caledon has bigger patches of brine cells to help produce more energy to produce more heat for its new environment. The colder, more upper reaches of the cup where falsums previously struggled. To also help preserve more heat, Caledon has thicker skin for better insulation. Ludius falsum. Ludius has, instead of brine cells, it has photogears, giving it a bunch of extra energy. Although this comes with the terrible downside of actually being edible to predators, this makes Ludius much more vulnerable, especially since Ludius still has no way to defend itself. Although it has grown bigger, and thanks to some special hairs in the end of its tail, it can smell and act when it thinks a predator is close. But sadly, close usually means right there, so Ludius is extinct. The second generation is made up of Miria repleti shredder and Salsus frere corpus. Miria repleti shredder. Miria is mostly aquatic, only coming out of the water to gain energy or just because it wants to. Miria, instead of suction cups, Miria has teeth and can absorb a small amount of blood, but Miria still can't eat. Miria has only 4 arms, the back 2 having bigger hands, I guess you could say, but both having durable but only relatively sharp claws. Miria is the biggest descendant of Falsus gramen. Miria is also the most active Falsus. Miria has, instead of simply a bag full of brine cells, a whole pad with high surface area to maximize efficiency, although this means everything but the pad and hands are edible to predators. The head of Miria has osteoderms that protects the head from damage and bleeding. Miria also live along creek and riversides along with ponds and lakes, thus putting them directly in competition with oases facies, leading either to the two ignoring each other or a brutal fight for territory. Miria is the dominant species. Salsum frere corpus. Salsum lives in the far upper reaches of the cup, and not only has its entire body covered in brine cells to produce more heat, but also has fur for keeping in that heat. The eggs and babies of Salsum have to live in a small pouch on the underside of the female. She also produces less eggs. The next species is Toxicus caniculum, splitting into Velox fodiens and Rosia hyder. Velox fodiens. Velox is not much different than its ancestor, only being longer and having a large protrusion off its face that is rotated in a way that helps dig out the ground in front of Velox. Rosia hyder. Rosia is a fully aquatic organism. Rosia is very maneuverable in the water. Unlike its Toxicus ancestor, Rosia has a pinkish color to help it blend in with its new environment, being the underside of Carnoradix. Rosia will also eat the Carnoradix that have fallen to the bottom of the pond or lake, or will prefer to eat the dead radix still floating. Rosia is also no longer toxic. The second generation is made up of only Durum facies. Durum has a keratin point on the end of its head to help with digging. The skin of Durum is completely gray now, being non-toxic since it almost never leaves the ground. The mouth of Durum is moved further back and is smaller to avoid obstructing the digging. Durum's eyes are smaller and can only tell between light and dark. Durum has a typically longer lifespan than its ancestors by 2 years. Durum is the dominant species. The next species is Admus fister, evolving into Cochleum armis. Cochleum is a bit bigger than its already big Admus fister ancestor. Cochleum is similar to Anthrophagus fister and hunts smaller animals, but instead of 2 mouths on its hands, Cochleum has a simple mouth. That's really just a muscle that contracts when the mouth needs to be closed, but the mouth also breathes inside of the shell's pores. But unlike Anthrophagus fister, Cochleum is able to eat any smaller animal, not just smaller fisters. 2 arms are in a spiral and can stretch, making Cochleum's reach deceptive. The second generation is made up of Interfectors fister and Domini fister. Interfectors fister. Interfectors is much faster than its precursors, also being the fastest member of Fisturidae. Interfectors only hunts other fisters, those being Anthrophagus fister, Domini fister, and because it can't tell and probably doesn't care, other Interfectors. The spiral arms of Cochleum have evolved into arms that can spring out in incredible speeds and puncture Fisturidae shells, whose meat will be carried up to the mouth. Interfectors is a yellow color instead of its blue ancestral color. Interfectors is the only fister in history with the ability to hear, although not great, it's something. This is the dominant species. Domini fister. Domini is smaller than both its Cochleum and Adamus ancestors. Although Domini is able to eat meat, only eating the flesh of the dead, it mostly gets its food from dust. Domini fister floats unusually high for its size. The next species is Nantantis aquaticus, which split into Nantantis pugnotaurus, Nantantis Macias, and Nantantis Hooverus. Nantantis pugnotaurus. Pugnotaurus's diet consists entirely of other Nantantis aquaticus descendants, unlike its scavenger ancestor who rarely hunted. Pugnotaurus will lie in wait at the bottoms of riverbeds and wait for its prey to swim overhead, in which it will be ensnared by a long tongue which pivots into 2 prehensile finger-like digits. Although Pugnotaurus is shorter than its ancestor, it's more powerfully built. Something universal for all Nantantis aquaticus descendants is that their breeding process is more refined. In other words, the males now have ovipositors in their mouth. To mate, a male and female will face each other, lock mouths, and then the male will insert his ovipositor into the female's mouth where he will deposit the gametes. Although Pugnotaurus is quite the predator, it is still commonly eaten by Folsom anguilla. Nantantis Macias. Macias has a unique ability completely unheard of anywhere else in the cup. The ability to extend their neck to the point where it tears the skin. This doesn't hurt the animal, but it is a gnarly sight to see. They use this adaptation to help catch prey. Instead of being an ambush predator like Pugnotaurus, is a pursuit hunter, chasing their prey into exhaustion, then going in for the kill. Although Macias doesn't feel any pain, if it extends its neck it can cause death. The blood released after doing this can attract Folsom anguilla. And the exposed muscles, veins, and arteries can get damaged by other animals much easier and by simply bumping into anything too rough. Instead of a large fin, Macias has 3 smaller fins. Nantantis Hooverus. Hooverus has internalized their rattle and have better hearing overall to improve their echolocation. Hooverus starts its life in an egg sac with dozens of siblings. Most of these don't make it to adulthood due to almost anything eating them, but the few that do make it to adulthood, life isn't much easier. One of the only reasons they aren't extinct is because of their absurdly fast reproductive and growth cycles, and also due to the fact that their food source is always in abundant supply. After the female's eggs are fertilized, it will locate a duobus capitibus and then chew a hole in the root where she would deposit her egg sac and leave it to grow. Hooverus is an example of niche partitioning. Its food source is mostly Carnoradix, same goes for Rosia hider. These two avoid competition by having Rosia hider eat the Carnoradix still floating and Hooverus eating the ones that have fallen. The second generation descendants are made up of Nantantis Elasticus, Nantantis Partitionist, and Nantantis Proboscadinos. Nantantis Elasticus. Elasticus is a small to medium-sized predator which tends to hunt baby and juvenile Oases facies, gigans dens, and Myria repleti shredder. This predation has caused all of the above to kill Elasticus on sight. Elasticus has evolved an extra digit on the end of its tongue. This allows it to grab and restrain its prey. Elasticus is also starting to evolve another rattle. This means that they have far better echolocation, but that it's also easier for other Aquaticus descendants to see them. Nantantis Partitionist. Partitionist is an omnivore unlike its ancestor. Partitionist has evolved another separation point on the base of its tail to offer more flexibility while swimming. Partitionist eats anything that can fit into its beaked maw. Partitionist has also evolved a longer tongue with a mildly venomous stinger at the tip. Partitionist uses this for three main uses, one being self-defense, second being killing prey, and third to cut up plants into edible bits. Although double the separation points means double the flexibility, it also means double the chance of death, and death indeed did come, and Nantantis Partitionist did go extinct due to its exposed muscles, veins, and arteries being bitten by everything. Nantantis Proboscadinos. Proboscadinos is both a scavenger and a predator, which uses its proboscis to rasp chunks of meat off of corpses and/or living prey. It has evolved a tongue which has a barb at the end of it to stab into prey and anchor onto them. Proboscadinos has developed a primitive sense of smell which helps it locate corpses. While it's small, it's one of the fastest Nantantis aquaticus descendants. The third generation is made up of Nantantis Nidalicus, Nantantis Cyclopsis, Nantantis Crocodilius, Nantantis Balticus, and Nantantis Tripleglossus. Nantantis Nidalicus. Nidalicus is a small to medium-sized scavenger which has 4 pores around its beak. These pores contain tendrils with a venomous barb at the end of each tendril. These tendrils are derived from its ancestor's tongue. These tendrils are used for both self-defense and to fight for mates. The males are barely bigger than the females. While they typically eat meat, if a Nidalicus is starving enough, they will eat Carnoradix buds. Nantantis Cyclopsis. Cyclopsis is a very unique Nantantid in the aspect that it has evolved a proper eye. This means that it doesn't have to rely on echolocation as much, therefore has become vestigial in the species. Cyclopsis is also one of the few Nantantis aquaticus descendants which has counter shading on its body. This helps it camouflage in its environment, which is typically lakes and rivers. Another curious feature of Cyclopsis is that it has developed its needles into a point where they are close to non-existent. Nantantis Crocodilius. Crocodilius is an apex predator in the swamps where it primarily hunts gigans' dens. This has resulted in evolutionary war between the two species, with gigans' dens evolving bigger tusks, while Crocodilius is evolving to grow bigger and all. This also obviously leads to frequent fights between the two, with Crocodilius having a win rate of roughly 63%, while gigans' dens has a win rate of roughly 37%. Crocodilius also has the strongest bite force of any Nantantid. While there isn't much competition, it's still impressive, at about 84% of Kaika Chaser's bite force. Crocodilius is the dominant species. Nantantis Balticus. Balticus is the fastest Nantantis aquaticus descendant by a long shot. It also has evolved a hard, bony casing around its jaws for enhanced bite force. If Crocodilius is the cup's crocodile analog, then Balticus is a mix between a tuna and an alligator gar. Balticus tends to only live in lakes and gigantic river systems since they need a lot of space to swim fast so they don't collide with anything at high speeds. Balticus tends to prey upon animals which come to the riverbank for a drink of soda, either killing them outright with one bite or dragging the creature into the soda and waiting for them to drown. The spot that Balticus has on its rear is used to fool Oases facies into thinking its cover is blown, since they share territory and prey on the same animals, and Oases facies is an ambush predator. Nantantis Tripleglossus. Tripleglossus has some very interesting adaptations, the biggest one being the split bottom jaw it uses to help swallow prey whole. Tripleglossus's tongue has split into 5 thinner tongues that use them to restrain prey. Tripleglossus's tail fin has also evolved to be browner to better suit its environment. Tripleglossus has the best echolocation out of any of its relatives. The next and final animal is Pena Army, splitting into Macias and Armis. Macias. Macias is a bit bigger than Pena Army. Macias spends more time flying, somewhat thanks to a small bit of membrane that stretches across the first few arm segments. Armis. Quator spends less time flying and more time walking. Quator's arms are better at filtering dust. Quator has a second pair of arms to improve filtering. Quator lives further up the cup and will save energy for when it gets colder by sleeping in some random place they find. The second generation is made up of Rauka Vigil and Coriza. Rauka have slightly shorter legs relative to their body size. Rauka has a tongue that can drink nectar from Nidalicus floris. The arms of Rauka are not only better at filtering dust, but Rauka's membrane runs further up its arms. Vigil oris. Vigil, who will now be referred to as Virgil from now on, is bigger than its ancestors. Virgil is too big to hang from Maximus foley, so it just sleeps under it. Virgil, unlike its relatives who are awake only at night, Virgil is awake at night and during most of dawn, typically just trying to find a place to sleep. The claws on Virgil's feet are sharper. Virgil has a mouth unlike all its other relatives, allowing it to eat, but Virgil only chooses to scavenge dead meat when he needs to. Coriza rhino. Coriza is the only member of this genus with fur. Fur it needs to survive in its new snowy climate it lives in. Coriza is awake during the day to help not freeze to death. Thanks to a lack of cold climate Fishturidae, Coriza is free to eat as much dust as it wants, being a lot. Coriza uses excessive food to produce a lot of extra heat. Coriza likes to huddle together under anything they can find. Coriza has shorter legs to prevent them from freezing. Coriza is the dominant species. The third generation is made up of Natatorius column and Titan Alas. Natatorius column. Natatorius is a bit bigger than its ancestors. A problem with Pena Army and all its descendants is that predators, more specifically Lataotus, will simply follow Pena Army until it needs to land. If Natatorius comes across this problem, it will dive into the nearest body of water, a death sentence for many animals, and occasionally for Natatorius. Titan Alas. Alas is the biggest descendant of Pena Army. Alas has the longest airtime out of all Pena Army descendants. Unlike all its other relatives, who can only see blue, red, and in between, Alas can see blue, red, and orange, yellow, and green. The ends of Alas's arms have sharp claws. These claws help with Alas's new predatory lifestyle. All of Alas's arm pieces are connected with a membrane, greatly increases airtime and efficiency. Alas is ready to attack prey during dusk, night, and dawn, only going to sleep after it's already become day. Alas prefers to hunt smaller prey that are currently asleep by swooping down, grabbing them with its four-clawed fingers and letting their remaining momentum carry them as high in the sky as it can, then dropping the prey. Other descendants make nests in or on whatever they can, but Alas specifically makes nests on top of two different Lapis folium descendants. We will talk about them when the time comes. But speaking of Lapis folium, it evolved into Dilapitum, Lapitidium folium, and Perditus follis. Dilatatum lapitidium. Dilatatum is taller than its Lapis folium predecessor. Despite living in a more watered or sodaed environment, Dilatatum still has bigger stone/sugar leaves. Perditus follis. Perditus is the only future descendant that was predicted in the original documentary. Smaller leaves to prevent transpiration, a bigger root system, and living in a hotter environment. The only thing that was not predicted is that the remaining leaves are now hard thorns. The second generation is made up of Lapis Needum and Colossus plantae. Lapis Needum. Needum has one circular stone leaf that can collect soda for the plant to use, or for animals like Alas and its babies to use as a bath. The circular stone leaf is used as a nest by Alas to hold its eggs, even though it's too small for the parent to sit on. Needum is, although shorter than its ancestor, has longer leaves. Colossus plantae. Colossus is the tallest Lapis folium descendant. Colossus would be the perfect food source for herbivores, but too bad Alas sleeps on Colossus's oversized leaves. Alas will protect their plant nest with ferocity. Alas will also only sleep on one specific Colossus unless it becomes too small or killed. Colossus is the dominant species thanks to Alas carrying their spores even further. The next plant is Maximus foley, evolving into Tria colibus and Abinatio sponda. Tria colibus. Colibus has a third stem connecting the roots to the leaf. The stems of Colibus are stronger with high-tension fibers spruined about. Abinatio sponda. Abinatio is taller than Maximus foley was. Abinatio's stems fused at a sooner point than Maximus foley's did. The second generation is made up of Immortalis virgultum, Toxicus hospis, and Conflata trunco. Immortalis virgultum. Immortalis, unlike its name suggests, is not immortal, just very strong. Immortalis can survive both without its stems and its roots, being able to store enough energy and resources to grow them back after losing them. Immortalis has 2 separate leaves instead of one bigger one. The stems of Immortalis are much stronger than before. Immortalis is the dominant species. Toxicus hospis. Hospis is bigger than its ancestors. Hospices are very toxic, making animals incredibly sick if eaten. Hospices get their poison from a symbiotic relationship with a toxic species we will talk about another day. And as hospice gets its poison, the species it works with gets free nutrients. Hospice is a common choice for Pena Army descendants to make their nests under or just sleep under. Conflata trunco. Conflata is the tallest member of this genus by far. Conflata's stem is almost completely fused into one, only the base is split. Conflata's has a big tuberous root that prevents other plants from growing near it, similar to some adaptations of a genus of tree did in the past. The next plant is Spiritus educatoris, evolving into Citus vitum and Os commandentis. Citus vitum. Citus is better adapted for drier environments. Citus is faster than Spiritus educatoris at decomposing, but it does not give as much nutrients to the ground around it, only about doubling the nutrient level. Citus is faster at reproducing as well, having stronger spores and pollen, being able to reach further. Os commandentis. Commandentis is taller than Spiritus educatoris and is more adapted to wetter environments. Commandentis is overall physically stronger than Spiritus. Commandentis can decompose bone unlike its relatives. The second generation is only made up of Robustus mors commandentis. Robustus is stronger than Commandentis. Robustus is quite a bit taller than Commandentis. Although to start growing, Robustus does need a carcass to grow on and decompose after some time, and with enough soda, Robustus doesn't need anything to decompose and survive. Robustus is the dominant species. The next plant is Duo foley, evolving only into Decum folia. Decum obviously has more leaves than Duo foley. Decum's main stem is taller than Duo foley's. In an attempt to not go extinct thanks to Angoradicatus, Decum evolved for more hydrated environments. The second generation is made up of Lenta Collis and Grand Collis. Lenta Collis. Lenta is a bit taller than Decum. Lenta's stems are stronger than Decum's. Lenta's female stem is able to store soda, allowing Lenta to survive in places that vary in soda levels depending on the time of year. Grand Collis. Grand is much bigger than Decum was, and also stronger. The male stem of Grand is covered in thorns, and the cap is the part that releases the spores. Grand has more leaves and lives in a wetter environment. Grand is the dominant species. The final species in this video is Triplex kowool, evolving into Multa folia, Cavum radix, and Mayor masculus kowool. Multa folia. Folia is taller than Triplex kowool. Folia has many more leaves on top of its main stem, a few more on its female stem, and has evolved whole new leaves on the male stem. Multa is better suited for mel-soda environments. Cavum radix. Cavum is better adapted for arid environments that vary in soda depending on the time of year. The roots of Cavum are hollow and store soda. Masculus has a much bigger male stem than Triplex did, releasing more spores. The second generation is made up of Colossus folia, Dilatatum feminum, and Dilatatum masculus. Colossus folia. Colossus is only able to survive in environments like flooded plains, river or lakesides, and swamps. Colossus has an incredible amount of leaves on its main stem, to the point where a high-strength core is inside the stem, almost acting like a bone to support the weight. Colossus also has more leaves on its female and male stem. Colossus is also taller than before. Dilatatum feminum. Feminum has an enlarged female stem and shrunk male stem and main stem. Feminum is also adapted for hotter environments. Feminum also has fewer leaves on its main stem. Dilatatum masculus. Masculus has a bigger male stem and smaller female stem. The main stem is no smaller but has fewer leaves. Masculus went extinct due to the fact that although the male stem produced almost too many spores for the plant's conditions to handle, the female stem was too small and low to the ground to get any healthy, strong spores, if any at all. The third generation is only made up of Magna, Femina, Kowool. Magna has a massive female stem and a tiny main stem. Its main stem also has fewer leaves, now only having 2. The male stem is only a tiny bit smaller than previously. Magna is adapted to live in very hot environments where Angoradicatus lives. And just like Silvoradix, Magna has a plan. If or when Ango attacks a Magna, these buds on the ends of the roots will prepare to disconnect, but not yet. Once Ango has started to wrap more roots around, the furthest possible bud will disconnect and start to work its way up to the surface, while the rest of the plant dies along with the other buds. After Ango kills the adult plant and the bud goes up to the surface, the bud will grow into a female stem and will grow all the other stems and extra buds. But one problem is that Angoradicatus does not remove its roots after killing another plant, it just keeps very slowly, but still growing. So the bud will grow all its new parts as far away from the root as possible, being not that far. Also, the bud disconnect is not perfect. Sometimes Ango finds the bud as it's killing the parent as well. And that's the end for this video on the future of the speculative biology inside a McDonald's cup.